Ciao, sono Matteo, uno dei coordinatori del JUG Milano. Volevo parlarti brevemente di un'iniziativa importante. Anche quest'anno come JUG siamo impegnati a dare supporto a Voxed Days Milano, una conferenza del circuito DevOps organizzata da sviluppatori per altri sviluppatori che nel 2020 torna a Milano nella sua seconda edizione. Magari in questi giorni di festa stai già pensando e pianificando cosa vorrai realizzare l'anno nuovo, quindi ecco un ottimo proposito. Acquista subito un biglietto per Voxed Days Milano, vedrai che è un piccolo gesto ma che darà grandi frutti nell'anno nuovo. Approfittane subito perché l'early bird scade a breve, quindi voxeddays.com/Milan troverai le indicazioni scritte sotto per tutte le informazioni e quindi ci vediamo presto.
Ask you if have you ever heard of this book, the Coding Dojo Handbook? It's an excellent book that it has this catalog of katas that you should practice. Honestly, I've done katas from here hundreds of times, hundreds. So all of them super interesting, practicing different kinds of challenges. Emily Becce. It's an UK lady, to my knowledge. Super good, super good. And all these exercises here have sometimes some link to a GitHub repository that you can download some starting code base that you can go on refactoring. This time, we said let's do TDD. I mean, actually, I would like to ask you, what kind of exercise do you want us to do? Do you want us to do a TDD one, a simple one, or a refactoring one? Who wants TDD? Raise your hand. TDD. Who wants refactoring? It's a bit slightly more TDD, so let's do TDD. And one of the best katas that I know of to practice TDD in 1 hour, because there are katas for hours, but this tennis game, have you ever, maybe you've ever done tennis game? Well, tennis has a peculiar way of noting points, one of which, I mean, it's like a love for 0-0. I mean, you have two players, and okay, let's do the whole stuff. It's more important besides the code is how you address the problem. You have some requirements, okay? As good developers do, you never read the requirements, right? Okay, it's no, you have to code, right? But however, TDD is the point of you have to force yourself to start with the first test, right? So from these 4 requirements that represent what you need to implement, you will start reading and you'll say, a game is won by the first player that has won at least 4 points in total. Oh my God, what a difficult rule. It's too difficult to start with. The next one, the running score of each game is described in a manner peculiar. Okay, scores from 0 to 3 points are described as low, 15, 13, 14. That's easier than the first one. So this one you will cut out. Let's see the third one. If at least 3 points have been scored by each player, and the score, this is complex, cut out. If at least 3 points have been scored and the player, cut out. The simplest the requirement that you have in this specification is this. If the running score of each game is described in a manner peculiar, So this is the simplest requirement. Let's read the context. Your task is to write a tennis game class containing the logic that outputs the correct score of the string for display on the scoreboard. As a string to display on a scoreboard. So it should return a string, right? So when a player scores a point, it triggers a method, some method, you don't know what method, to be called on the class, letting you know who scored the point. Later on, you will be called score, which will return you the string that you have heard of. That string will represent the score that should be displayed on the scoreboard. Interesting. So the method should return a string. Good. Now, given that there are 2 players and if they score no point at all, it says love for nothing, then what is the simplest possible test to write? Given that, so if for a new game that no one has ever won a point, what should be the score? Love, love. And there you go, writing your first tennis game test. So you start the DD of always with a test, right? This test will have the first test should be like empty game. Let's name it empty game. And this one says something like, well, when on a game I get the score of it, then this should return me a string s equals. Now, this already it doesn't compile, so this means it's a failing test. So I will need to create the class tennis game. Tennis game here, and I will quickly put it there, and there you go. This is the way that we should work. With the, I like to work. Tennis in the left hand and implementation there. And this is core. Now, this method doesn't exist here, so using the beloved alt enter, you will here return anything. Now, this is production code. You are not allowed to touch production code unless to fix a test. So there are, I think they should, unit testing. Come on, unit testing. No, not yet. Unit testing. Where are you? Unit testing, yeah, let's see the, no, not this one. The training unit testing, Okay, so I'll switch directly to the TDD part. Yeah, the question is, would you like to unit test this? I hope so. Black holes, the end of life, end of death. Okay. So, where the heck are you? No, further here. Somewhere around. Yeah, here. Good. Now, TDD is actually a discipline that allows you to grow software in small increments for each of which you write the test before the implementation. That's basic stuff of TDD. So you have to write the test before you have a test. Let's make it. Now I will use. I'm not sure if you have here a cert J. I don't think I have it. I don't even have a cert. Yeah, a cert. So where is a cert equals? A cert equals, and there is not that there yet. But press Control Space once more, and there you go. Static import from wherever it is, a set equal, and I will expect the first result to be what? Already I have to take a decision. We didn't even implement nothing in the production code, but we need to take a decision. What is the format of the return string? Is it love, love? Is it love minus love? Is it love space minus space love? There is a decision you need to take at the API level right before you implement anything in production code. And this is interesting. It focuses you to clarify the API right beforehand. And this should be equal to actual, to the string which is actually returned. Good. Now, this, of course, if you run it, and you should run it, and you should see it the wrong one. You should see it failing. If it fails, you should be glad because you are now allowed to touch the production. You are allowed to touch the production, right? What should you do here? The simplest possible way to make the test pass is to love, love. And the test is green. Green, green. Perfect. Next one, I will just keep them here and look at them from time to time. Next one, the next possible test to write. Easy, and this is import static, of course. Well, the next, no, technically speaking, I will cut to the point. Normally, I will create many tests. At the end, I will figure out they are basically input, output. Just for simplicity, don't do this in real life. I will just put more tests in one single. It's bad in practice, but we have to stretch it into a little time. So I will just continue to write asserts here. Why is it bad in real life? Because if this test fails, you wouldn't know which one failed. But you can control click and see the line which failed, right? So technically speaking, that's this famous single assert rule that I don't give a shit of, honestly. So I will put as much tests as reasonably possible in a single test because it's so easy to debug and less tests is sometimes better. Next test that you should write. What should you write? Actually, this will lead me to some. No, let's respect the flow at the beginning. The next test case. What should I write? So, I mean, back to the specification. The specification says that in case you get 1 point, you should get 15. What should be the next test? One player, player one scores. The name of the test is not that good yet, but 15 love. Now, we will have to make this pass. Now, the test, if you write it like that, the test, if you write it, it's a buggy test. It's an incorrect test. Why? What is it missing? The score, of course. So tennis game dot score player 1. You already have a decision to take. How do you model players? Would you model 1? God forbid. If you model 0 is the first player or 1 is the first player? Or should it be player dot first with an enum or something? You already have to take a decision, right? So, folks, I won't try to finish the kata. I want to take conclusions out of it already. So I will claim that 1 for me represents player, the first player. So I will create, but not score, right? It should be a different method that allow. The specification didn't tell us what method will be called. A method. So we need to take a decision. How will we name this method? Let's name it. So you tell me. Something with point, right? Point 1 by player 1. Perfect. So we already have the decision of the API, right? And then what should we do here? What is the simplest way to make the test pass? Now, it currently returns love. So there is this trick. And I know that some of you may think in advance how you can model the score, how you can increment the score, but the simplest possible way in this point is to make this a field. It's kind of stupid if you look at it too closely. It will just say equals love, and in case 0.1 by player, no matter what yet, I will do what? Score string equals exactly what we expect. And we will copy the string from test together with the bugs, with the typos. Let me just... yeah, and if you copy from test to production, look what you can do. You can copy the typo. This is why people don't copy-paste code from one place to another. They prefer to retype it again. Okay, just retype it just to make sure, right? Good. And then, if you run it, let's see what happens. It's green, perfect. And now let's run the whole class, and it's green, perfect. Next test. What should be the most simple test to write next? What do you think?
2 players score 1 point.
Both players to score 1 point. There is a simpler. So you say 15-15. This is a too complex test. What's simpler than this? Love 15. So you will always strive to the next simplest possible test you can ever write. Player 2 scores. And I put here 2. Good. Make sense? You want to see it failing? It fails? It fails. Good. So you are allowed to go to production. And you go to production code and you say what? If. Do you have you ever heard of transformation priority premise? Just take a photo. I mean, transformation is from Uncle Bob. It's the way how the code evolves when you're doing TDD. It's tricky. But from nothing, there was an if. Where is it? Unconditional to if. So we do this, we wrap this in an if, and we say only if I equals 1 should I do this. Otherwise, score string equals, and I will type it, love minus 15. There you go. And now the test should pass. Passes. Great. Next test that we should write. Tell me. Actually, only stop. We have duplication 3 times. This is the actually. There's not yet duplication. No, too few. Let's wait for some more duplication. What will be the next test to write?
What players score?
2 points or what?
Or both players score.
Both players score. Oh my god. Okay. And I should give 1 point to this one. Both players score. Oh my god. And then you say, okay, what should I do? Now comes the fun part. What should you do? A switch. If what? If, oh my god. So the first one is 1. So when the second one is if. At this point, you see the mess coming to you, you know, you comment, you run the test again, you are on red. You would like to refactor the existing code, but you are on red. In the first 6-9 months that you do TDD, don't refactor on red. It's very dangerous. So technically speaking, one way is to comment the last test that you wrote, back off a bit, look at the code should be green, good, and if you are on green, you are allowed to refactor. Meaning, very carefully do isofunctional, don't add more logic here, just refactor the same stuff to do it in a different way. How could you do it? Well, so again, the goal is to refactor the same code and to write it in a different way. Well, tell me, how could I refactor it? What should I do?
I could go the score instead of the string.
To score the integer, okay? So private, static, why not, in, player 1, score, okay? Equals 0, okay, 0, and player 2 score, okay? Now, what should I do here? And I will show you one thing. The test still pass. The technique that I will show you just now took me years to master, really. Look, I will add the code without breaking the existing one until I fully replace the implementation. So the point is to remain on compilation without failure, to remain without errors in code. So I will add here that in case the player now, by the way, what is I? Come on, no. This is player number. In case player number equals 1, then player 1 plus plus. In case the other one, player 2 plus plus. Make sense? The tests still run. I'm adding code without breaking nothing behind. Now, what should I do here? Well, ideas, come on. What should I do? Switch. Nah, it's too heavy for now. A list. Ooh, a list. A list of what? A list of strings of score. But I'm not allowed to add any more functionality besides what is already there. So the one way to do it is this. If player 1 score equals 0, then what? Well, I will need a string s that I will concatenate to. Exactly. S plus equals what? Love. Else, s plus equals 15. And now, I will carefully concatenate a dash, and I will copy paste this again to code still compiles, but I didn't yet changed it completely. And now, s. Progressively, it crashed. Why? Let's see. Player 2 score, pum, 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 pum. It's a static variable. Oops. So what should I do? And it's a static variable. And now, this is a classic case in which you have a test, you want to analyze it, and you run it alone. We've all seen that, right? You have a test failing on Jenkins, you test it locally, you run it, it is green.
Jenkins test again.
I know, cannot reproduce. One fix. So the problem is that when this happens to you, it means that you have coupling between tests. There can be thread locals, static variables, dirty objects in a Spring context. There can be files on disk. There can be power mocks that you forget to unmock. Stuff, heavy stuff. It couples things together. So then, in our case, it's easy to figure out that's static, that's messing with us. Again, nothing should be static here, but if you do this, the problem is you can't call it anymore like that. So then, instead of all of this, I will say game. Now the question is, where does this instance come from? Let's make it a field. And this field, I will make it new directly here. And run again. So I converted the instance I converted the code to an instance class, and now the test I will pass. Okay? I did something risky. If you paid attention, I refactored both production and tests. I heard it because it's less time, but technically you should only touch either here, run tests, either here, run tests. I've tackled both of them, and if in real case scenario, if you don't pay attention, However, This is now grayed out, so nothing to think of. Alt enter. Remove field because it's not used anymore. Bye bye. And there you go, just by removing. But then comes the fun part. Look, there's duplication. We know there's duplication. We've just copy-pasted code. So we would like to extract this part. Now, so folks, I would like to do it first slow motion for you, and then with IntelliJ. Now, if I extract this block, is it identical to this block? Not quite. This differs. Okay, then, in slow motion, I will do something very weird. I will extract a variable out of this variable. This is absurd, but I will name it score. Why did I do that? Let's zoom in. Because now in this block, if I extract this block now will have to take a parameter from the context that I've extracted, so if I put this here and I extract, I get this beloved score here. If I extract together with this or with this, I don't take this. I don't need the score as a parameter, but I want the parameter. Why? Because I intend to use the same function 2 times, one for the player 1 and one for the player 2. And then now if I extract this, I will say translate score. Just wait a second, translate score. And then I will inline back the variable. So this is a typical scenario. You extract variables, then extract methods and inline back variables. I've did it dozens of times. And inline back. But now, this was a slow motion version. Let's go for the fast forward style with IntelliJ. If you happen to extract directly this block, IntelliJ will offer translate score this weird dialogue. What does this do? Even the title is creepy. It says extract parameters to replace duplicates. What the heck does that even mean? Extract parameters to do what? That's exactly what I did. Look. So often we did that back in. This is very recent, for less than 1 year, IntelliJ. So often we extract inline expression. They did it automatically for us. However, today in the training we had a scenario in which this dialog popped up and suggested us to extract some variables to replace code in 2 places, but we did not wanted. I mean, it just happened to just look like the other code. It was different code, but just happened to look like. IntelliJ said, let me replace it. If we did yes, it would couple together the two places, calling a single method, although the 2 places were independent use cases, were independent features. Because they are just syntactically similar, IntelliJ offers it to replace it everywhere. So pay very much attention with this feature. If you ever see this dialog and you do not expect to see it, if you don't expect to see this dialog, press keep always. It can be dangerous. It can couple together things which otherwise don't have anything to do with one with the other. But this is what ends up. Then, what do you feel about passing in a string and returning back the string? What the heck is this? No. So, progressively doing this, it would mean like I should define a string as here locally. I will shadow the parameter. This doesn't compile yet. But then, guess what? I will destroy the parameter. Do you see where I'm going? I will have the function to return the new value to add, not to append itself. This, I don't want to do inside. I want outside to be doing. But let me go slow motion. S will delete, and when you save delete the parameter, your eyes should be here. When you save delete the parameter, it disappears from the call places. Right? It's the same as change method signature, but done automatically for you. But then this, if you run it now, you will see that you've kind of screwed it up because you forget to do what? Plus equals, very well. It's plus equal here, which is way better. Good. Now, technically speaking, if you concatenate it to nothing, this, it's actually what? Return. Good. And then this is no longer reachable. Bye-bye. This is grayed out. Bye-bye. There you go. Oh, someone said that you want to switch. But let's just wait a bit, right? And then here, there is this, now, to me, many years I was annoyed by concatenating, you have to edit and stuff, after which I discovered Alt Enter on plus equals. I just pressed Alt Enter, nothing more. I didn't do anything really, just Alt Enter. I can't possibly do any mistakes. IntelliJ does it syntactically. It's no mistake here. Alt Enter, Alt Enter, Alt Enter. Alt Enter programming, Alt Enter driven programming. Yeah, it's all green. Now, next feature. Let's uncomment the test that we were about to write and say that, okay, points won by player. This doesn't compile anymore because now the game is now, yeah, that's it. 15-15. What happens? The test is already green. What the heck? Now, if you ever see a test, a new test, already green, there are two options.
It's wrong.
Either the test is wrong or is overlapping with what was already implemented. The test is not wrong, it's correctly formulated. The problem is that by mistake, I already implemented this feature. When I refactored, I automatically covered this case also. In which moment you have a decision to take. Would you leave the redundant test or not? Now, technically speaking, you would think of, okay, then it will ask for 30-30, 30-15, 15-30, love 30. There will be a lot of duplications going on. But however, you might want sometimes to leave the duplicated test in place for documentation purposes. To show the next you that, oh my God, it is possible to do equal score. Okay, just for documentation purposes. So you can tolerate a bit of duplicated tests, of overlapping tests, just to document your code better. But then let me take for the next one. 30. 30 love. How do you get to 30 love? Well, you have to give 2 points to the first one. 30, and love. And the first thing you need to do when you write a new test, run it and see that it fails. It fails. Good. Now, what should you do? Easy. It's very easy. You have to support 30. What should you do?
Convert to the switch case. And
Convert to the switch case first, indeed. It's a good way. And then just add here 2. And say 30. Some of you are angry because the order is messed up, right? The others of you are worried about, wait a second, but does it make a sense we have a default for any other score? It's a bit weird, right? And now in production code, what would you do here, really? You will put what here?
through exception.
First of all, case 1 here, and then afterwards, Alt Enter, Enter. No, Alt Enter, insert default branch. Nice. Because you need to have a default for every switch, right? And then, of course, you need to reorder these a bit by syntactically moving the whole blocks together. Okay, 0, 1, 2, perfect. Now run again. The test should pass this time, and the next test will make us suffer when you see the same thing 3 times. Which time? This is already becoming annoying, right? And let's tolerate this time, but this time only, 40. 40 love, run, you will see a problem. Then here, I will just duplicate this, and I will say 3, and say 40. For
Both implementation and test.
it's actually the US style of writing, and the UK, or the other way around. I always mess them around. But again, yeah, you should do what? You should do very careful copy-paste from the specification, of course. 40 it is, 40 should be. 40 here, 40 for you. Thank you. But then, this costs money. Sorry, it still works? Yes. Sorry. Then comes the interesting part. What can you replace this with? There are multiple options. The worst one is if. No, don't do this. The other one is a map. Or if you are more inventive, you can figure out these are actually zero-based index values which can go in a string array. Labels, I don't know. And you'll put here very nicely love, 30, 40. Not only more compact, but again, you are losing something. You feel it. 30, 40, 15. You are losing, not 15. You are losing the fact that it's not obvious. I mean, it is obvious for you, but someone else would miss that this is 0 index, this is 1 index. There's a bit of trick. So actually, a map could suit me better in this case. A map could be better. Especially, you know, the economics of code tells that the one who develop software don't normally have to maintain, oftentimes are not the ones who maintain the code. So if you know it when you write it, it might also mean that the maintainers won't know it, right? It depends on the style of working, but so this will actually be converted to return labels of player one, which is wrong name, so you don't hesitate to say score. Right? Don't just wait and see what happens. Good, and then run. And so, honestly, what the heck is this method? The name of the method is longer than this, so no, kill. Inline everywhere, replace the implementation with this. I mean, replace the call with labels, arrow, and that's it. And this actually is a public static final, right? There you go. Private, good. Anything that gets born in this world is private. You know, everything that gets born in private. So, you do have a problem with the opposite sex in the opposite gender in this community here, in this city. I think there is a real problem, folks. The dynamics is way better. I've been in both kinds of teams, male only and mixed, but it's way better in mixed. Because men are just like, I'm the best, and they end up kind of fighting each other, right? The woman can will chill you down. Then next, this is ugly, so what should you do when you see such a thing? You will try. Now, technically speaking, if you ever develop code and you end up with such an API, because it annoys you with the API, you should be adjusting the API because it's hard to test. But basically, TDD gives you this hint. Okay, wait a second, your API is not usage friendly. Do something about it. And you might want to say, I want to give to the player 3 points. But other times, the API of the class that you develop is fixed, like it's our case now. In which case, what would you do? And that's an interesting question. What is normally recommended is to build a testing framework. But testing framework in our case means what? A for. From 1 to 3. In doing this, you agree? It's okay, yeah. And then killing this just to test again. It's all fine. And guess what? If I take the same approach here, what should I put? I should put 2 here. Okay. And then now these 2 syntactic blocks. Should we try the IntelliJ Magic once more? Extract this. Oh yes! Oh yes! Dun, 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 dun. Let's see what happens. So, Jesus-driven development. Accept signature. Yes. All. What happened? GDD is not a good one. It's set player score. This is the set player. Yeah, player score. No. Which player exactly? Player 1 score. We have a problem. You see it? Player 1 score. And this is point, right? And I'm calling it here and here. Good. But now, how about this one? Or how about, let's implement this. Because this was a nice requirement. This means at least 3 points have been scored by each player and the scores are equal. Okay. Let's try that. Okay, so we removed the duplication a bit. We are in draft state. I agree. It is not a perfect state, but let's see what happens if we add more dirt, more garbage. Let's see what happens. So I will have to do this, which means this. I will test first that if both players have scored 3 points, and now I will need here 2. You see it? I need 2. What do you do? For writing the tests, you will edit this one. And I will show you one super powerful refactoring, which is called change method signature. So this will adjust this signature and will allow you to add one other int, which is the player number. By default, the method player1 will take here what? 1, exactly. Aha. Okay. Let's refactor. And your eyes should be here. 1. Good. Why good? Because here I will pass 2. Okay, but the function doesn't yet do anything really. So, yuck. If. Do I need an if here? No. No.
Oh, you have to have a
I need to
case
force.
one.
I need to force. No.
No, you have to replace the one with
Oh yes, sorry. It's late. I've woken up at 3 a.m. your time, so it's yeah. And this fails. Yes, it fails correctly. Giving me what 40. Oh, come on. But again, this is wrong. I should put this here, right? And now I should expect this, and got 40. Aha. And this is easy to fix. So easy to fix. With a if. Excellent. If what? If player 1 score equals player 2 score, because I had a beer before, and return this. Okay? It's okay. This, you can't even type anymore, and if I run it, it's wrong. Bang. Okay. Oh, half an hour, I have a bug. Cool. Well, the spec says that, and the scores are equal, but there is one more part. At least 3 points have been scored. So now the question is, and player 1 score at least 3 points. Does the test pass? Yes. The rules of TDD say that the 3 rules: write production code only to fix a failing test. Although you will foresee the end, you will refrain yourself and take its baby steps. The second rule: write 1 test for any feature not yet implemented. It must fail beautiful. When it fails, mwah. The third rule: write just enough production code to pass the test. Just enough the production code to pass the test. Nothing, not an extra feature, nothing. We broke this rule. With what? You laugh, but I won't. What the heck is this? This is extreme style TDD, honestly, but that's the point of practicing, to realize that you've added an extra feature. What you covered with tests is just equals, because tests are still passing. What you're really missing is another test, this 4, which says 4 to you, 4 to you, test. You see it failing, and because it fails, you will come here and put. Some people say, "Oh no, add an or." But this is like, no, this is stupid. Really, to do this, this is stupid. No, you won't do this. You won't go against the flow. I mean, it's stupid. But if you were able to force yourself to go from an equals to a greater than equals, I think that's even a transition somewhere there. Not sure. No, I don't see it yet. But the point is, you enhance the functionality, expand by. Yeah, you get the point, right? Good. Now let's return here. Do you see duplication in this code? Okay. What could you do? Well, this is one testing framework. You can build one better one that does what?
Takes the 2 scores.
Exactly. Void set both scores. And I will say int player 1 score, int player 2 score. This would be nice to have in my API of my production code, but I don't. So that's why I build around it a nice testing framework. And this does what? Exactly this, but carefully doing here. Player 1 score. Look, again, playing golf. Player 2 score. Okay? And then set both scores here would mean to replace 4 and 4. Here, it's actually 3 and 3. You see it? Now, I could go on and go on, but there isn't even a better way of testing it. Do you see duplication here? It's a bit extreme what I would go for. But
You're passing the same parameter 2 times?
no, it's 3. No, yeah, but
Three lines of
It's always the same input with
you notice that after setting the scores, you always came game.score. Then what do? What if, in a better word, what the heck is this? I mean, to call game.score, now folks, this is super deep, you will see in a moment. Return Zang. Test. Green. Now, what does this lead us to? Do you see what happens here? I basically have a function that I give 2 parameters and it returns me a string. Whoa, because that's actually what's there. But they formulated it in the specification to have a method that changes stuff, that then they ask them stuff. And this actually is the so-called the temporal coupling that we discussed today. Temporal coupling, you have to call first this, and then score. And you can hide this temporal coupling by wrapping it around. Let me just, I can even inline the actual, some of you might not agree with me, but look how this could look like. Now, setBot score has a better name to say translate score. And then, let's move on. This is actually string equals. I won't implement more features, I will just refactor this in all the possible ways and draw the conclusions. This translates score. Okay? Here, again, translate score. Here, bye. Okay, and then translate score. Translate score of what score? 1, 1. That's it. And let me just copy paste this. The low 15 is 0, 1. And then this is 1, 0. And basically what I'm doing here, I'm replacing all the usages. And now something dramatic will happen. Something unexpected will happen. Now, you know, in normal case, in normal production code, private methods go below. In tests, private methods go the first, always. Because there's like introduction, the context, and then bang, the test. So let me just move them up for now. And then what do you notice? Something, parameterized, cucumber feature files, there are a lot of directions, but one more thing, whenever you think parameterized, think again and do feature files, always, with tables. Beautiful, beautiful code. And if you present your business with feature files, they will hug you. Let me show you why, just quickly. Oh no. Shit. I have a problem with my IntelliJ. No, I don't know what really happens. It just hangs sometimes.
It's Windows.
Windows probably, yeah, Windows. It passes in several minutes, seconds.
Try Control cancel since you're on Windows.
Control on what?
No, I will check.
Oh, come on. Escape. How was it? Got translate, Shift F6. Now, yes, and actually, if you see the typo, Alt Enter, rename to translate. It's even easier. But then, set player one score, good. Now comes the dramatic part. This thing can go in. Whoa. What the heck am I talking about? Meaning that this can be given as a parameter, game. I like to give it the first one. Game, pair one score, pair number 1, and that's it. Now, what does it really mean is that this function is the so-called pure function. It takes 2 inputs, returns 1 output. There is no side effects, there is no mock, there is nothing. Input, output, which is... I could, yeah, why not? That's a clear sign that, yeah, it's a statement. You know? Static. Good. Interesting. So basically, I'm wrapping around this testing API with a beautiful API that I can test with one-liner tests, which is incredible. And I would really like to show you that, but open recent. Unit testing, where the heck are you? Unit testing. Okay, just quickly. If you ever can transform a requirement in a table, if you ever go to your business with an Excel file, they will cry in tears. They will hug you. They will kiss you. It's incredible. So whenever you can reduce a problem to a tabular style, don't ever edit it to do a feature. Send them the feature by email, have their confirmation on email back, and there you go. There is no room for misunderstanding. Each of these actually translate. Wait, look, I even have the tennis game. Look, there you go. These translate to some steps in some. Just reading on this, because this is text file. No one can claim he didn't understood this. What the heck? It's not programming. This is text file, right? Beautiful. So that's why not parameterized, but even further. This one, if you can, right? Because parameterized can only be understood by developers. This one can be understood by anyone. But now comes there is one more interesting stuff here. So to translate, okay, more than equals, okay. I think it's more than equal. It's okay. It's okay. Now, let me just anticipate. Advantage. There are all the other ifs. No, the points we got all the points that you wanted out of this. So a pure function is easy to understand. Now,
maybe you have to remain the set player one score to set player score.
Oh my God! Sorry. Yes, I didn't saw it. Set player score. Perfect. But again, if you can, modify the production API if you are allowed to. Good. Now, the famous, the unique, the one and only, the inevitable, the red-green refactor mantra. This is deep. This is one of the deepest slides I ever did. 3 or 4 books are in this slide. It's incredible. It goes like this in several articles, dozens of articles. The first thing in TDD, you write a failing test for a new feature. You have something to implement. You have a new feature. You write a test. Good. Around the test, they should fail. They should fail, and you should see it failing always. Then you write the production code, and you want to make it pass as fast as possible. That's a key point. Kent Beck invented this technique, and he actually said that we wanted to force the developers to make it pass as fast as possible, writing as little production code, making a mess. We wanted the developers to make a mess. Why? Because we wanted them to be sorry afterwards. That's exactly the point. By forcing yourself to do we created static fields. We copy-pasted ifs, remember? Horrible. We've seen horrible things. It was there in this phase in which we wanted to make the test pass. It's a mess after we finished. We played golf. We played that thing with click, 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 and 2 letters enter. Right? The point is to make it pass as fast as possible. If they are green, you will refactor. You will refactor either production or test, not both sides, because if you break both in the same way, yeah, you get the point. By running obsessively, compulsively the test, you know that you cannot break anything. You cannot break anything. The point is here to eliminate duplication, to make the code clean as possible, to do well-crafted code. That's the place to employ readability. It's the place where you take your duck out and you explain the duck your code. You know the rubber duck programming? Debugging. Not debugging, rubber duck programming. You explain the code to a duck. Right? Then what you do, you will select another feature, but always start with the simplest cases. That's fundamental. Otherwise, you will block. Otherwise, you can't go past. Start with the simplest flows, and ideally start with the happy flows, not to assert what happens if you pass a null to a function. No, start with the happy flows. Then you run the tests. Now, if you run the test and the test is already green, you have a problem. There can be two things. One is the test is buggy and it doesn't actually test anything, or it's overlapping. You could keep the overlapping test for documentation purposes in case the scenario is remarkable, like 15-15. But I didn't add it 30-30, 30-15. It's overlapping, brutal overlapping. Now, when you fail a test, always be sure that it fails with grace, meaning the failure message is suggestive, and that's not a null pointer, or expected 1 but was 0, or something, it doesn't say anything. If you can, make it more expressive. Here, however, it's super interesting, this part. You have to make it pass in several minutes. If you can't make the test pass in 10-15 minutes, ideally, you should revert. You should revert and retry. My God, what the heck is that? So if you get stuck or if you break things that you didn't expect to break, you should go backwards in the time. We did that. Remember? We commented out the test. We returned on the green state. We refactored stuff. We came back and uncommented the test and move on. So when you block or you just can't make it or you break things, go back in the flow. This is advanced. It's called degenerate the solution. Super heavy, super interesting. Now, there is one missing step here. When you write a new failing test, there is a phase of design which is missing in many books and many perspectives. You remember when we had to take the decision, how is the string formatted? Love minus love or love space love? That's a design decision, how to name the methods, how to structure the data structures. These are here when you create the new test. It's super deep, that part. You should not miss that part. It's fundamental, right? The design in TDD happens here, right? If you read about the outside-in style, the Sandro Mancuso style of doing stuff, it deliberately has two loops. One exterior loop for designing the acceptance full stuff, and one micro level testing, unit testing per class, right? Super interesting. So TDD, again, is not the blind man's stick. It's the plow you are strong enough to carry. The point is TDD won't get you to the right solution. TDD is a tool that makes your life harder now that you can sleep better tomorrow, right? But you have to know where you're heading, right? TDD is not a magical bulletproof, you need to whatever do it to get you. No. You have to foresee the design, that's the point. You have to know where you're heading, right? Rules of SIP, do two schools of thought. One of them is the test-driven development, by example, the so-called Chicago school. The other one is the London school, in which the outside-in style of TDD goes. This is the core book of their ideology, London school. This is the so-called mockist style, and this is the mock-free, or I don't know how the classicist, they say. And there was this famous comparison. This is a mock. There is this famous comparison between the two solutions. I don't know why that's not a link here. It should be a link. Wait a second. I should put a space here. Excellent. Again, and now click. Excellent. I showed you also, I showed them to them too. There is a comparison between so both Sandro Mancuso and Uncle Bob did the same solution, the same problem in two different styles. And what's left afterwards is a GitHub, in which there is a branch, incredibly, named Uncle Bob. Woohoo! Uncle Bob wrote code 2 years ago, and the code is here. That's absolutely amazing. And if you look at it, you will find out in the test that he built his own DSL in order to be able to test things easier. He built a testing framework around the REST API. He builds stuff just for testing, using which he built tests like this in a fluent, nice API, expressing things in the language of his application. So this means to build a scaffolding around the thing that we tested. This goes in the direction of building this mini testing framework. So don't hesitate of building a testing framework around your whole project. More than, I would say, more than relying on mocks. Because mocks are fragile, you know that. You felt that. So the point is, yeah, right. What does TDD stand for? Test-driven development or test-driven design? Ha! Interesting decision. If you do design, that's a good thing. Testable design is a good test. It's good production code. It's actually proven heavily thorough code has a better design. Should we TDD everything? Martin Fowler, articles. Is TDD dead? Very interesting. He actually says no. No. He says no. But this is a heavy weapon to employ on the beasts, not on any fly that you encounter, right? Stop. It's late. Enough. That's what I had. So the main points. It's actually this time. I will share all that I've showed you today with Mario, and probably he will upload on some meetup. I'm not sure how we. Yeah. But this is the thing that you should print, almost, and have it close to you. And one other thing, in time, maybe if you've been practicing TDD for a while, you saw that you don't write just one test in advance. You write the first test when you start designing, but after the first several 3, 4, 6 tests, you will write 3 or more tests in advance because you know where you're heading. Anyway. And always remember to degenerate. In case you block, try a simpler feature, coming back the flow. Super deep. So this is super deep. Okay? Wow, 10 o'clock. I never spoke until 10 o'clock. Thank you all for having. Yeah. I want to have a selfie with you. And yes, 10 o'clock. I can't believe it. 10 o'clock. Yes. And because you stayed with me so long, I have stickers for you. Stickers. But now we have to move fast because at 10 we have to exit the building, I heard. So here we go.
Oh, grazie. Thank you.
Stickers. Please take one.